The gravitational field strengths of the surfaces of the Earth and the Moon are 9.8 and 1.7 respectively. If mass of the Earth is 81 times the mass of the Moon, what is the ratio of the radius of the Earth to the radius of the Moon? Alright, so let's write some of this stuff down. So, gravitational field strength of the Earth is 9.8. Gravitational field strength of the Moon is 1.7. And then we're told the mass of the Earth is 81 times bigger than the mass of the Moon. We're trying to work out the ratio of the radius of the Earth to the radius of the Moon. Okay, so we're considering gravitational field strength. So let's look at this equation. G is equal to gm over r squared. We're trying to work out a ratio of radii. So actually, just very quickly, if you're asked to work out the ratio of, let's say, A to B, you can write it like this. The ratio of A to B can also be written as A over B. You can give it in either form, both are correct. Now in this case, we don't have a ratio in this form, as we can see it's just a number, so we are therefore going to be using this form here. Okay, so here's our gravitational field strength equation, rearranging for radius, gm over g, and then square root both sides. So I can say from this, because gravitational constant is a constant, I can say that r is proportional to root m over g. And then, if we're trying to work out the ratio of the two radii, re to rm, what we can then do is, using that proportionality, we can say that this fraction will be equal to the square root of the mass of the Earth over the gravitational field strength of the Earth, divided by the square root of the mass of the Moon, divided by the gravitational field strength of the Moon. So because we're considering the ratio of the same quantity, i.e. radius, then when we divide the two things, the gravitational constant will just cancel out. So you don't have to use proportionalities here. I find it a little bit easier. There's a bit less to cancel out in our fraction. If you were to include the g into both of these parts of the fraction, they will just cancel out in the end. So either way, you'll end up with the same result. Okay, so next step is to combine this to make one single square root, which is then mass of Earth over gravitational field strength of Earth, all over mass of Moon over gravitational field strength of Moon. And then this becomes the square root of, so we have a fraction divided by a fraction. So when you simplify this, it will end up being the mass of the Earth times the gravitational field strength of the Moon, all divided by the mass of the Moon multiplied by the gravitational field strength of the Earth. And if you're not sure why, think about what happens if you do AB divided by C over D. This is the same thing as A over B times D over C. This here is effectively what we have here. We have one fraction divided by another. This is how you would simplify it, and when you do so with what we have over here, you end up with this. Okay, so now we can use our numbers. We know the mass of the Earth is 81 times the mass of the Moon. So we can rewrite that first of all as the mass of the Earth over the mass of the Moon is 81. And then we can put that in. So consider this as two fractions multiplied by one another, the ratio of masses to the ratio of the gravitational field strengths. So for the first ratio, mass of Earth over mass of Moon, we know that is 81. So this turns into 81. And then gravitational field strength of the Moon was 1.7. Gravitational field strength of the Earth was 9.8. And that's what we were given up here. And then put this in our calculator, we end up with 3.74, etc. And that rounds to 3.7, so our answer would then be A.